So hi guys, welcome to another video. So today we're going to be answering the activities in chapter 7, which involves IP addressing. So we'll start first in this topic 7.1.1. So we have here the conversions, binary to decimal. So binary to decimal conversion this is an easy activity. So it just makes you practice the conversion from binary to decimal until you perfect it. So what we need to do here is rely on this table. We have here the base, exponent, position, and bit. So what we're going to do here is the binary value, which is this in the bits, the 01001001. So we will be going to determine the value of this to get the decimal conversion of the binary value. So here we have the 1 in 64. The first one is for 64. The second one is for 8, and the last one is for 1. So here we have 64. 64 plus 8 is equal to 72, plus 1 is equal to 73. So you're just going to add up from the position. So you're gonna rely with this. This is the value of this, of the octet. So this is the octet, which has the 8 bits. So I 73. So let's add a new value here. So we have 128, 16, 8, 4, 2, 1. And the bits is 1001 1111. So 128 plus 16, 144. 144 plus 8 is 152, plus 4 is 156. 156 plus 2 is 158, plus 1 is 159. Check that. We're correct. So let's go on to the other activity, which is decimal to binary conversion. This is just the reverse type of conversion. So here what's missing is the bit. Is this bits the ones and zeros in the octets? So what's given here is the decimal value, because we will be converting decimal value to a binary. So I have my 191. So we will just determine on what values can we add up to form 191. So each of the values here which is valid to be part of this 191, you will just add 1, and if not, just add 0. If it's not possible with this value. So here we have 191. So the first 128, yes, you're gonna add up that because this is bigger than the 128. 6 plus 64. If we had 128 to 164, we have 992. So we're gonna reject that. So 128 plus 32 is 160. Can be yes. 160. So what's left is 31 value. Last 31. So 160 plus 16 160 plus 16 is 176. What did I say? Yeah, 160 plus 16 is 176. So let's add that. 176 plus 8, is it possible? 176 plus 8, yes, it will be 180. It will become 180. Wait, what did I? 128, 32, 16, 176 plus 8 is equal to 184. 184. So we're going to add that. 4, 184 plus 4, 188, and 1. So 188 plus 2, 190, 190. And if we add 1, we have exact 191. So we're trying to check that. We're correct. So that's it for the decimal to binary. So we'll go straight here to ending. So this is quite a difficult thing to do, because you need to use the ending process to get the values for some of the octets here, the network address in binary and network address in decimal. So here for the network address in binary, what you're going to do here is rely on the host address in binary, which is these two octets here. You will never mind first this last two octets, so you go straight here. So that will automatically be the values from the host address in binary. 01, 01, 00, 10. Okay, so to get the last two octets here, you need to rely from the host address in the subnet mask. So the ending process, it involves determining the values, which is the ones here, these ones, and check if they have also the value in the subnet mask. So if the subnet mask has this all ones in the octet, so it means that you will just copy the host address in binary value octet 001000010, and this, so you're gonna match if they have the same position of ones here. So in this case we don't have any, so we're gonna write zeros there. So in network access in decimal, the first two octets is also the same as this in network access in binary. What you will copy here is the first two boxes here in the host address. So you're gonna type 10 and 82. So here in the last two octets, you need to determine the value of this, network access in binary, the third octet. So what we have here is the 128, 64, 32. So we have 32, 16, 8, 4, 2. So we have 2. So 32 plus 2 is 34. So 34 is here at the host address. So it still depends on the value of this. So there's a case where in network access in binary, the third and the fourth octet, there are times where the subnet mask in binary is all zeros, or sometimes the ones doesn't match the positions of the host address and the subnet mask. So the sometimes doesn't match here at the host address, the third and the fourth. So if the subnet mask here is 0 and you're getting the network address in binary, so you will automatically write zeros here, 0 octet also here. If this last two octets in the subnet mask is zeros, so it will automatically be 0, and the network address in decimal will also be 0 here. So that's it. So here we have 0, all 0, so we write down zeros. So we got it correct. So done with that. Okay, did I skip something? I think I skipped something. Oh no. Okay. So we're here on the next activity, which is unicast, broadcast, or multicast. So here we have connectivity between six PCs. One is the source host, while the other has their own IP addresses. And what we're going to do here is determine the if the address type is unicast, broadcast, or unicast. So we have here. So this activity contains a timer. We also have the start here. You need to start that. So you need to answer it before the time runs out. So the destination IP address will appear here, and you will determine if they have if they need to be if you need a unicast or a broadcast or multicast. So let's try it out. So 237.192.126.17 group. So we're gonna check out for the if it matches with the PCs. It matches with the PC's addresses. So next 192.168.105. So it will be a unicast. So next again, I'm gonna need to answer the other. So 192.168.10.2. So here's the address. So you can see 192.168.100.2. You're gonna click that because once it already contains the exact address from this destination IP address, you're gonna search that. So 225.577.126. So we have here the two because they're from the 225.5.77.126 group, as you can see. So we're done with that. So here we have the pass or block IPv4 addresses. So in the topic of this, there are we have public and private addresses which the ISP or the internet service provider is blocks or pass depending on the type of addresses. So if the private addresses will be the ones with the 172 front, the 192 and the 10. So you will not it will not block the ones with the with other values or types of addresses. It only blocks the private addresses, which is the 172, 192, and the 10. So let's try to start this. You shall pass, but you're hanging. Okay. Start. So pass, you shall pass. It's kinda lagging, I'm so sorry. Pass, you shall pass. Oh. Okay, this messes up all these stops. But it's from this topic. So this is the private address blocks. So we have 10, 172, and 192. So that's what I have known. As you can see here in the image, it blocks the IP addresses from the networks. So you just keep that in mind. IPv4 issues and solutions. So in this activity, we have these terms again, the IPv4 and IPv6 terms. So the dual stack tunneling and translation are solutions for the IPv4. So we have much it here. So 128-bit address, 340 undecillion addresses. We have IPv6 because it has undecillion addresses, has many addresses available. And 32-bit addresses have IPv4. Transport an IPv6 packet over IPv4. So we have tunneling. So uses NAT, so it will automatically be translation. So here we have dual stack. We're correct. So here in this translation, the NAT64, it means the network address translation, or with the 64-bit, which helps convert the IPv6 or the IPv4. Also, the tunneling, it uses a tunnel for the IPv6 to pass through with the IPv4 network. And the dual stack, it allows it allows both protocols to have the same network segment. So that's it. So here, practicing IPv6 address representation, we have here the preferred format. What's missing is the omit leading zeros in compressed format. In omit leading zeros in the IPv6 conversion, we need to just remove the zeros up front and leave the last digit aside. So if we have 0, then we have all zeros. You will not remove it all, you just leave 1. So 0 db 8. So we have db 8. So 1111 000 200. So in the compressed format, you just use semicolons and write them down. So there, db8 1111. So if you encounter this consecutive zeros here, you can use the double semicolon. So here we got it correct. So we'll just answer. I will not answer that all. I'll just answer some of this. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Oh, G, D. Oh, why did I? G, D, F, 0, and 1. So the compressed format for this 2013 0 1 2 3 4, 5, 6, 7, 8, 9, AB, C, D, E, F, double semicolon and 1. So we got it correct. So even even if the even if the there are zeros here, it doesn't mean that you're going to do the semicolons on both sides. So you just like choose which side you're going to write it on. So that's for the IPv6 address representation. So identify types of IPv6 addresses. So here we have three terms here. So we will put them in their respective positions here, their descriptions, and it can be repeated. So here we have unique internet routable IPv6 address, dynamic or static. So global unicast must be unique. So FEAT double semicolon 1. So this is the link local because it uses that the address or the for the link local address, and this is for the global unicast. This is used for interfaces for the network addresses, and typical IPv6 prefix used to indicate the network portion of the address is the 64, which the IPv6 has the 64 bits used to communicate with other devices in the same IP. So we have link local, and we're correct. Find more. We have connectivity verification. Oh, shit. Okay, so we have the syntax checker here. So what we're going to do here is the routing configuration for the IPv6, setting the IPv6 address using this. So what we're going to do here is we're at the global config. So oh, so in setting the IPv6 address is more of the same like the IPv4. It just adds the v6 next to IP and type in the needed address given for the IPv6. So no shutdown. So it's changed state to up. So we'll try to exit and it's wrong. So there has been a problem here. But it is supposed to be the exit was supposed to be right. So as you can see, the phrase gigabit internet 0/0 IPv6 address. I read correct. No shutdown. Stay to up. And we've typed in exit, but it doesn't go to the global configuration mode. So we can't go on with the second interface, which is the gigabit ethernet 01. So we're just we're just gonna do this exactly, but we can't in this syntax checker. So that's just how easy it is. It's like setting the IPv4. No, that's it. Just try to show it all. And as you can see, it doesn't have the exit here. So it's kinda bugs me. No shutdown, no exit, straight to interface. So that's kinda wrong from me. So we have the last one. Oh, wait, I've skipped something. Okay, so I skip this. So public or private IPv4 addresses. So we're going to determine from these IP addresses if they're from the private and public class. So here, the 172.1635.2 is here, the private, because I have told you that the 172.192 and the 10 is from the private classes. 192 is from the public, even though it has the 192, it has different format. So this is different. So here we have it. Yes, trying to check that. So I'm gonna correct. So keep in mind the 192.192.10, 192.72. This 192, but it has different format. It doesn't have the like 3 digits the next after the period. So that's it. So there's another other syntax checker here, just finding for it, searching for it. Oh, so oh yeah, this is the next one. So we're going to verify the address configuration for the IPv6. So show command to list very brief summary. So show IPv6 interface brief. So this is the same of the like showing the interfaces in the IPv4 address interfaces. So you just need to type in the show IPv6, not the show IP. So there, enter the show command that will display the IPv6 routing table. We have show IPv6 route. So there we have the routing table. CL. Now we have the addresses directly connected. So the three interfaces is connected. So verify. We're going to ping that. So this is the same. We'll just type in the IPv6 address type. So 201 DB8 ACAD 110 DB8 ACAD. So success rate. So it's replying. The router is pinging the PC and it replies and the success rate is 100%. We're done with that. So that's it for the chapter 7 IP addressing. So stay tuned for my chapter 8 and 9. I'm gonna create that. I'm gonna answer that. And that's all, and thank you for watching. Bye bye.